Everyone, it's an honor to be here. Welcome to this Ishango.ai fellowship presentation. We are very excited to be here today to present to you our project about satellite imagery analysis for Undercover classification. About ourselves, I'm Jeanette. My background is mathematical science and machine intelligence.
I am Nasser. I am a Cameroonian. I have a background in physics and mathematical sciences, and we love data science.
Yes, it's true, we love data science. That's why we are very excited to work on this project with Philip Morris International Company. Thank you, PMI, for this opportunity. So, our company are looking for how to differentiate possible different land cover surface in order to identify the region in which there are more likely tobacco fields. So the company want to have visibility on those tobacco fields because all ground operations are run by supplier. The company depends only on the information from the supplier. It's very important to have visibility on those fields because the company wants to monitor how farming practices are performed, because the price of tobacco leaves depends on the crop quality and the yield, which is directly linking to the living income of the farmer. It's very important to solve this problem because it will help farmer to identify the cause affecting the crop quality, as well to increase the crop productivity. After understanding the problem, to address this issue, we developed the methodology for automated land cover classification using remote sensing. So the process of remote sensing starts by the source of radiation, which is the sun. So the sun emits the radiation on the ground. There is interaction between the emitted radiation with the ground. Then there's the satellite sensor record some reflected radiation. There's transmission of the data to the ground receiving station. And there's interpretation of analysis of those data in special software. Finally, there's application of analysis of the results. How this remote sensing applied to our problem is we use the remote sensing monitoring and the publicly available data sets online. We are able to identify different type of cover and classification. Let me hand over to my teammate to tell you the method and tool we used.
Thank you very much, Janet. Hello, everyone. Here are some of the tools we use to tackle this problem, and the methodology we use is as follows. Firstly, we import publicly available Landsat images in Python with Google Earth Engine API. Then we train locally a random forest using scikit-learn, and we convert the estimator into a string representation that can be understood by Google Earth Engine. The next step is to convert the scikit-learn classifier into Google Earth Engine classifier, and you classify your image using Google Earth Engine. Finally, you plot the normalized different vegetation index time series for your area of interest. The normalized different vegetation index is a metric that quantifies the amount of vegetation you have in an area of interest based on the reflection of the near-infrared lights and the red lights in that area. And using random forest classifier, we were able to classify 3 types of land covers, which are vegetation, water, and bare soil. Having a closer look on the map displayed before you, the vegetation is represented by the green, the bare soil is red, and the water is blue. We later moved to the model evaluation. We want to see how good our model is. So the metrics we use for the model evaluation is the accuracy, the precision, the recall, and the F1 scores. And on averages, our values ranges from 97.2% to 98%, which shows a very good performance. You can see this on the table display before you. Then we analyze the Ndvi time series for each of the classes we were able to classify. We started with vegetation. This is the Ndvi time series for vegetation. On the y-axis, you have the Ndvi value, and on the x-axis, you have the day of the year. And you can see how the Ndvi values fluctuate over the period of time. Also, you can see there is a certain periodicity in the fluctuation, which says that the area of interest, that's the vegetation, shows some seasonality, where the high peak stands for the harvesting period and the low peak stands for the planting period. We now look at the Ndvi time series for water, which is negative, and it matches what we expected for the Ndvi time series for water because there is no vegetation on water. However, sometimes it goes above zero because we have some algae that are able to grow on top of water. And then we look at the third class, which is bare soil. The Ndvi values varies in the range 0.0 to 0.1 and doesn't go above 0.1, which matches the Ndvi values for bare soil. In working on this project, we face some challenges, which is first, the availability of a training data set for supervised crop classification. And to overcome this challenge, we use a Timoland cover label data set found in Google Earth Engine, and we were able to classify our area of interest into the 3 classes. Now, the limitation of this solution is the diversity of the classes in our training data set. We were able to classify just between 3 classes: vegetation, bare soil, and water. However, we know that we are more likely able to find our tobacco fields in the vegetation class. So far, it was good. Now look at the impact of the work on the population and globally and to the company. Remote sensing helps in improving crop productivity and contribute to greater yields with improved quality, increasing the living income of farmers. And also, remote sensing reduces time-consuming manpower in order to provide quantitative and timely information over larger areas. And Ndvi analysis help in monitoring and controlling the proliferation of harmful algae bloom, which produces toxic and harmful effects on people, fish, and marine animals and birds. Thank you very much for your attention.